So how do you guys see the distinction between like different data availability approaches, what kinds of applications each ones are appropriate to, and how you expect that to evolve in your ecosystem in the future?
So when it comes to data availability, I'm always more comfortable when it goes to basically Ethereum, because it makes the security analysis much simpler. There's a single dependency. You don't have multiple dependencies with links between the dependencies and so on. So I think it's always simpler. I totally agree as well that there are some use cases where it's absolutely acceptable to have lower security requirements. And I think there's another category, which is actually we can accept to lose the data. The famous example is everything related to social network. You're not going to put on-chain all the pictures of all the world. It's just not possible. But it's kind of interesting because here it's data that you can accept to lose. So if something happens, okay, it's lost. We've got the accounts, we've got some stuff on-chain. And this separation between, there's a part on-chain that is, we're sure that we're not going to lose it. And another part that we can accept to lose, it's fine. It's an intermediary step between a validium where, okay, actually, very likely you will not lose it. But you have just a more complicated security analysis to do. So there are a little bit those three categories, in my opinion.
I think like people tend to think of this as like two like polar opposites. Like you have on-chain and off-chain. But I think there are a lot of interesting models where things could be in between as well. Like you don't have to put all the data on-chain, or some things could go on one data level, like L1, and some things could go to some other DA layer, for example. A good example of this, like in Polygon mining, for example, we have this distinction between like accounts and nodes. And you could say accounts are on L1, but nodes could go somewhere else. And what this means is like whatever is in your account is secured at the same level as Ethereum, but whatever is in flight has a slightly different security guarantee. So like if you're like an in-flight transaction may have a lower security guarantee, but usually don't transfer your like entire account worth at the same time. So that's just fun, interesting way. I know there's other designs like Volition where you can have accounts live. Sometimes like users can move in the same account from one data availability model to another. There's I think Adamantium that Starknet guys like published at some point where it could automatically switch from one model to another. So I think there's actually a very interesting space in between those polar opposites where you have some data sometimes in one place and other times in another place, and the user decides where the data goes.
I agree. It's going to be probably we will all converge around these hybrid models where every chain will not be a strictly a rollup or a validium, every zk chain. And I think everything is going to be zk in the future. But we will all have volitions and even deeper things where users host part of their data for certain accounts. But there are clear use cases just for rollups. Obviously, you want to host most of your net worth in a rollup because you want to derive full security from Ethereum without compromises. I think that's going to be the case for not just, most of the value on layer 1 and on the layer 2s are held by whales, by power users who are smaller numbers, but they have a lot of value there. Like you think of all the liquidity provider, arbitrageurs, market makers, they hold their value in something that they absolutely need to rely on. So security is part of UX if you want. So they will certainly be on the rollup. And if you think about the enterprises and institutions and banks, most of them will clearly prefer a validium where they fully control the data, and that's just the reality. I don't like it, and I hope we will eventually build much better tools purely on chain that people own and fully control. But we will have a continuum of the systems, and the banks and institutions will have their assets issued in private validiums where the privacy is provided out of the box, but it's still fully interoperable with the rest of the Ethereum ecosystem.
From my perspective, I think that for general purpose protocols, it just makes sense to be a rollup, just purely because if you have a lot of apps deploying on you, etc. minimizing third-party dependencies just makes sense, because let's say, whereas if you're an app-specific chain, then I guess it depends on a specific use case. As you said, if the chain is securing billions of dollars, then I would say it's probably best if you continue functioning as a rollup. Whereas if it's like a gaming chain or something that has less value in it, like and is more towards geared towards storing data, or just like making certain state transitions, it just makes more sense to use a Validium or an Optimium in case of an optimistic rollup, because for the vast majority of that data, you don't need the full security of Ethereum. It's perfectly fine to compromise a bit, but the trade-off is that you get significantly lower costs.
Completely agreed there, and I think, to me, it's a matter of essentially, it's not going to be practical for a while, at least, to have everything be a rollup, and kind of fundamentally, like you need to compare to sort of what the next best option is. And I think that kind of there are a lot of sort of DA approaches coming along that certainly, like everyone has said, would not want to be kind of the main kind of primary ecosystem rollup chains, but sort of fundamentally do enable use cases that don't exist otherwise. Just to sort of on kind of, I think there's another part of your question that we kind of went less into. One, just a minor disagreement. I think you said that over the last few months, there's been arguing over what's an L2. I would say over the last 5 years, it's the sort of definitional problem that's plagued us for a long time. And in my mind, on that front, the thing that like I'd really love to continue to see more of is sort of less kind of like, it's very appealing to sort of like have these sort of terminology buckets and kind of like you're an L2, not an L2, you're a roll up, not a roll up, what have you. But I think the really kind of valuable thing is sort of the one level deeper of the kind of what are the assumptions being made when I use this system? What am I trusting? And like, for example, sites like L2Beat that sort of dig into security frameworks to me are a kind of great resource there. Although there's this tension, which is how much can we expect sort of end users and even application developers to actually sort of fully understand those details, which has sort of always been kind of a challenge.
Mm-hmm.
I have the feeling that the data availability as a consensus, I mean, how much bandwidth can handle a consensus in data availability. This is a problem that's a relatively new problem, and we don't really know what are the limits there and what are at least the theoretical limits there. I know that the Ethereum Foundation for sharding and all, there are some theoretical problems, but I mean, it's very young. It's a very young problem. There is not many chains that has been designed just for data availability itself. So, but the feeling that I have, and this is just a personal opinion, is that in a few years, data availability is going to be very much solved. I mean, it's not going to be free because everything, I mean, it's the consensus is not going to be free, but it's going to be cheap enough or very cheap, so that the problem that maybe we are having now, where we store this data availability, I have the feeling that maybe in 4, 5, 6 years, 10 years, it's not going to be a huge problem as it may be right now. And here I would like to hear opinions on that.
I think one other thing that is interesting from data availability standpoint to me personally is ability to maybe push a lot of the data completely off chain into the user. So like only the commitment to the account or something, some of the account state goes on chain, and the actual contents of a user's wallet and things like that are stored locally by the user. This enables like a lot of scalability. Obviously, it has its own pros and cons and trade-offs, but this is like when we think about where does the data go, we always think some other chain, but I actually think that another option is just the user stores the data locally and is responsible for the data, and then just provides either zkP or data kind of proofs in a stateless way to the network whenever they need to execute a transaction.